Hello there. Have you ever played a game where you have to roll a dice? That's right, the fun little cube with different numbers on each side. Imagine that I ask you to roll a 6-sided die, and I want you to roll a 6. For each roll, you have a 1 in 6 chance to get a 6. But what if I asked you to roll 2 6s in a row? Your chance is now 1 in 36, which is a lot less likely. Now imagine I ask you to roll 10 6s in a row. The chances of that happening are so incredibly tiny. You're more likely to find a grain of sand that I've marked somewhere on all the beaches in the world. This is easier to see if we were able to roll the dice millions of times, which with enough time, like millions or billions of years, still very, very unlikely. That's kind of how evolution supposedly works, except the requirements for life are much more complicated. But here's where things get really interesting. In biology, especially when it comes to the development of life and complexities, every roll of the dice isn't independent, meaning you are not starting from scratch every time you roll. The results from the first roll affect the second roll negatively or positively, and so on. To make it even more complex, think about playing a video game, where if you make a wrong move, the game doesn't just reset, but your game console bursts into flames. That's what it's like for living cells. Most mutations are not just benign, but can be really harmful or fatal to the cell or organism. Scientists who are interested in these things are beginning to reconsider evolution as the only explanation for how life came to be so complex, especially when they look at things like DNA, the thing in each cell that makes you, you. DNA is like the world's most complicated programming language, and now that we know about it, it's absurd to think it have just arranged itself by chance.
DNA stands for deoxyribonucleic acid. It's the instruction manual for life stored inside every living cell, from the tiniest bacteria to the giant blue whale, and of course, us humans too. DNA is the programming language for all of biological life, and it is the most sophisticated computer program ever written.
In computer language, we use a combination of 0 and 1 to write code. We call these binary codes. But in DNA, there are 4 letters instead of just 2, A, T, C, and G. These letters stand for 4 different chemicals: adenine, thymine, cytosine, and guanine. The order or sequence of these chemicals is what encodes the instructions for building everything in your body. A small error in the DNA can lead to serious problems. However, DNA has built-in error checking and correcting mechanisms to fix these mistakes, just like how modern computers work. Remember, evolution is not just a theory that says life evolves. It says it evolves by random chance, meaning that there is nothing that is causing it to become more complex, more ordered, and more sophisticated, but accidental collisions of matter and energy with no intelligent purpose behind any of it. This violates a physical law of the universe known as entropy. Now, how do we explain entropy? Have you ever watched ice cubes melt in a glass of lemonade on a hot day? That's a simple way to understand entropy, a big word scientists use when they talk about something called the second law of thermodynamics. Now that's a really fancy term, but it all comes down to something pretty simple. It means everything in the universe, from ice cubes to stars, likes to go from being neat and tidy to becoming more mixed up and spread out over time. The special law, the second law of thermodynamics, says this is what naturally happens everywhere and all the time in the universe, from your ice cubes mixing up to the stars spreading out in the sky. Entropy, or the mixed-upness, always gets greater over time. Have you ever noticed how if you don't clean and organize your room for a while, it gets messier and messier? In fact, it seems easier for things to become chaotic than for them to magically become tidy again, right? That's kind of what the law of entropy is about. Scientists have noticed that in the whole universe, things tend to go from being neat and orderly to becoming messy and disordered over time. So the idea that things are randomly evolving, from less order to more order, violates one of the laws that we observe in the physical universe, the law of entropy, among others.
Now let's think back to our DNA. As we've learned, DNA is like a super complex instruction manual for life. It's incredibly ordered and specific. So if left to itself, according to the law of entropy, DNA would tend to get messed up and disordered, rather than getting more complex or better ordered over time. Just like your room that doesn't clean itself up, but instead gets messier. It would be as if your toys started randomly moving around, and your books started to rearrange themselves or mix their pages, the chances of them forming a perfect order by themselves, well, that's highly unlikely. That's why people find it hard to believe that something as intricate and orderly as life could have been created just by chance or random mutations over time. It seems to go against this law of entropy that we see happening all around us. While we do observe some beneficial mutations and adaptations to environments within species, we do not have any examples that we can observe of one species becoming an entirely different species. Remember, since this is all random, we should not only expect to find positive transitions, but we should also expect to find many more instances of failed random experiments and rolls of the dice than examples of success. This is because in order to get the positive variation, you have to get exactly the right combination of dice and the exact combination of code in the programming language, DNA, or you will end up with monstrosities. Yet we do not see the world littered with all the failed experiments as one species supposedly transitions to another by random mutations as accidental factors collide to change the language and the programming code.
Here's an analogy to consider. Imagine a room filled with 1,000,000 monkeys, each with their own typewriter. While monkeys can't read or write like humans, they love to play with objects. So, these monkeys begin randomly pressing keys on their typewriters.
Each time they hit a key, it's like rolling a dice with 26 sides for each letter of the alphabet. What are the chances they'll write a phrase like, "We hold these truths to be self-evident," a line from the Declaration of Independence? Or what if we wanted them to write the Declaration of Independence or even the Constitution?
Well, the chances are incredibly small. So small that it would likely take longer than the universe has existed for it to happen just by chance. The chance of something as complicated as humans, or even a single-cell organism, arising by random chance, seems as unlikely or even less likely than those monkeys accidentally typing the Declaration of Independence. Now, let's imagine that each of those monkeys is like a simple cell, not a human or animal, but a tiny living thing that you need a microscope to see. Now, this simple cell is, in fact, incredibly complex. It's like a tiny city where different parts do different things, all at the same time. There's a power plant, mitochondria, that generates energy. A factory, ribosomes, assembles proteins, which are the building blocks of the cell. There's a library, nucleus, holding and protecting all instructions, DNA, to make this city work. It's a bustling place, with many activities happening at once. Just running one simple cell is like orchestrating thousands of workers in a city, each doing a different job, but all working together smoothly. Can you imagine our monkeys doing that by hitting randomly at the typewriter? When people refer to a single cell as complex, they mean it's more intricate than even the most fanciful story our monkeys could accidentally type. A cell is more like a library, or even an internet of information, rather than a single document like the Constitution. Randomly creating a cell by chance would be like expecting our monkeys to accidentally type out an entire encyclopedia, not just the Constitution. It's more plausible that an intelligent designer, rather than chance, is responsible. Think about creatures like us, made up of not just one, but trillions of cells. The human body contains approximately 37.2 trillion cells. That's like giving each of our 1,000,000 monkeys 1,000,000 typewriters. To function properly, these cells must communicate with each other, like pieces of a puzzle fitting together to create a beautiful picture. Our cells do more than carry out their activities. They cooperate, communicate, and sometimes even sacrifice themselves for the good of the whole body. If creating a single cell by chance seems challenging to imagine, how about trillions of cells in the human body, all different, but all working together in incredibly organized ways?
There have been various attempts to explain the origins of life without considering the existence of God. This approach, called naturalism, is essentially a religious belief system that requires specific beliefs that exclude the idea of God. However, with the advent of new discoveries in genetics and the life sciences, such as the discovery of DNA, we understand that even at the smallest microscopic levels of our universe, there is breathtaking complexity and sophistication. Even the raw building blocks of life, such as the so-called simple cell, are more complex than anything we have ever created as a civilization. Science supports the idea that life is a created thing, not an accidental process. This is important because it means that God created you with a purpose and that your life has meaning. Many atheists are abandoning the theory of evolution and seeking other answers, such as multiple universes, the idea that the universe is a giant computer program or aliens created us. However, all of these lead to the same hopeless conclusion, with no personal relationship with a loving God that we can know, who wants to spend eternity showing us his kindness and the wonders of his infinite being. This is what eternal life in Jesus gives us, a future and a hope that the world without God does not have.